see the verification of an ear for lifting. Leave a suggestion for new videos in the comments. And remember to continue uploading more videos, subscribe, like, and share. And for your donation and to be able to continue with the channel's topics, you can do it through PayPal as indicated in the video description. A lifting system is intended where one ear must support a load of 1,500 kilograms, and if we consider impact load that corresponds to 25% of the lifting load, the total lifting load that each ear must support is 1,875 kilograms. In the analysis of the resistance of the material for the ears, taking into account ASTM A36 plates with a thickness of 25 millimeters. Structural steel, in profiles, sheets, or plates, A36, with a minimum F and equals 2,548 kilograms per square centimeters. FU minimum equals 4,077 kilograms per square centimeters. A modulus of elasticity, E equals 209,0418 kilograms per square centimeter. And a specific weight 7,833 kilograms per cubic meter. The filler or welding material, welding E70, Fu equals 4,955 kilograms per square centimeter. Already knowing the properties of the steel materials and the filler material, that would be the welding. To analyze the resistance of the lifting ear material, it will be done by the yield resistance due to tension, fracture resistance due to tension, shear tear resistance, and finally, the resistance of the weld. All results will be compared with the resistance of the weld design, according to its arrangement and the total length of the joint. It is important to take into account how the ears will be connected if they are hooks, shackles or links according to the following table of shackles for a load of 2 tons. The bolt will be at least 16 millimeters for. The figure of a lifting ear is presented, with the following dimensions, a diameter, A width, B, on the perimeter of the hole. The free height, C. The length of the weld, D. And the thickness of the lifting ear plate, T. For our design, we are going to use the yield or breakage stresses, in kilograms per square millimeters. So, for the analysis of the resistance of materials, the creep resistance due to tension in the entire area of the material will be verified. We will obtain a resistance RD1, with a yield 0.9 times Fy. And the thick area, which would be the length of the weld, D, and the thickness of the plate. We obtain the thick area. By the Fy, we obtain the RD1. For resistance to fracture in the presence of the holes provided for the links or shackles, we are looking for a resistance, RD2. This resistance is 0.75 times the ultimate tensile stress, Fu. And the effective area, AE, which would be the weld length, D, minus the diameter, A. For the thickness of the plate, DH, is the 2 mm increase in the diameter of the hole. Substituting the variables, we arrive at the value of RD2. For tear resistance to shear forces, we are dedicated to the search for resistance, RD3. This resistance being twice the length, LC, due to the thickness of the plate. Due to the shear fracture stress, ZUP, which would be 0.6 times the ultimate tensile stress, Fu. We already know the values of the weld length, D. The diameter, DH. The length, LC, the subtraction of the length, D, and the diameter, DH, between two. The thickness of the plate, T, we have the ZUP. And we get RD3. Now, for the strength of the weld, we will have a resistance for, that would be 0.75 times per 0.6 times the ultimate strength of the weld, Fu. The effective area of the weld, AES, and the sum of 1 and half the sine of the angle, raised to 1.5. We know the filler material FEXX. The effective area of the weld, which will be the throat of the weld, and the length LS. Our 90 angle. The effective throat of the weld, GEH, and the cosine of 45. H is the leg that forms the throat of the weld. We get the effective throat, GE. We obtain LS minus D. Also, the value of the effective area, AES, is arrived at. To finally find the value of the resistance, RD4, we compare all the results, RD1, RD2, RD3, RD4. We take the minimum value of the resistances, ROD. The minimum resistance result will be the maximum welding design load, for the dimensions of the lifting ear presented in this video. In conclusion, we have the required weight per ear, 1,500 kilograms. We are asked for a percentage per impact of 25%. Therefore, we will have a required weight plus the impact of 1875 kilograms in each lifting lug. The total load on each lifting lug would be 1,875 kilograms. If we divide the resistance RD of the ear by the total load on each lifting ear, we will have a factor of 10, and we are asked that there be a safety factor greater than 5. Being 10 greater than 5. Therefore, the dimensions of an ear, and its welding length, are sufficient to support the maximum load in each of them. Remember to leave your like and share. Leave your suggestion for new videos. For your donation, you can do it through PayPal, as you find in the video description.